Good morning. Exercise 7.1, sum number 13. Two numbers are selected at random without replacement from the first 6 positive integers. Let x denote the larger of the two numbers. Find e of x. Okay. Two numbers are chosen from the first 6 positive integers. So what will be n of s? It will be 6c2, that is 15. Let x denote the larger of the two numbers. Now, first 6 positive integers are 1, 2, 3, 4, 5, 6. So x can take which values? Will you say 1 also? No, because x denotes the larger of two numbers, right? So x can assume values 2, 3, 4, 5 or 6. Now when x is 2, positive integer less than 2, the only positive integer less than 2 is 1. So in that case, n of x equal to 2 is 1. So what is p of x equal to 2? 1 upon 15. Similarly, when x is 3, the other positive numbers less than 3 can be 1 or 2. So how many sample points in favor? 2. So what is the probability? 2 upon 15 and so on. Right now. So when x is 2, you have to actually write this. At least write for x equal to 2 and x equal to 3. So when x is 2, positive integers less than 2. Actually, this was correct. There is only one positive integer. Positive integer less than 2 is 1. So for x equal to 3, there are two integers less than 3. So n of x equal to 3 is 2. So p of x equal to 3 is 2 by 15. Similarly, p of x equal to 4, 3 by 15. X equal to 5, 4 by 15. P of x equal to 6, 5 by 15. Now it is e of x, sigma xi pi. So 2 into 1 by 15 plus 3 into 2 by 15 plus 4 into 3 by 15 plus 5 into 4 by 15 plus 6 into 5 by 15. 70 upon 15, that is 14 upon 3. Sum number 14. Let x denote the sum of the numbers obtained when two fair dice are rolled. Find the standard deviation of x. Now when two dice are thrown, what is n of s? 6 into 6, that is 36. Actually, in board exam, you cannot write this. You have to actually mention those pairs. But for CET, see, when two dice are thrown, minimum sum is 2 and maximum sum is 12. Let me explain. So there is only one pair which gives sum 2, that is 1, 1. So from the beginning and from the end. So 1, 1, then 2, 2, 3, 3, 4, 4, 5, 5, 6. Means there are 6 pairs, right, from 1, 6 to 6, 1, in which sum is nothing but 7. But in board exam, I repeat, you have to actually write those pairs, write those sample points. For example, 1, 1, here 1, 2, 2, 1, here 1, 3, 2, 2, 3, 1, and so on. Okay, this is for CET. Right now. Now, how will you define x? What will be x? X is sum of numbers on uppermost faces. Right down. Sum of numbers on the uppermost faces. Therefore, x takes values 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. As I said, I repeat this. This is for CET. Here you have to define X, so X can take values and so on. I have directly written probability distribution, but you have to mention this, that there is only one sample point in favor of X equal to 2. So probability is 1 by 36 and so on. So this is probability distribution of X. Now what is E of X? Sigma xi pi, 2 into 1 by 36 plus 3 into 2 by 36 plus 4 into 3 by 36 up to 12 into 1 by 36. So if you take 1 by 36 common in bracket, you get 2 plus 6 plus 12 plus 5 into 4, 20 plus 30 plus 7, 6 are 42 plus 8, 5, 40 plus 9, 4, 36 plus 30 plus 22 plus 12. So E of X comes out to be 252 upon 36, which is nothing but 7. What is E of X square? Sigma X square pi. So 4 into 1 by 36 up to 144 into 1 by 36. So if you take 1 by 36 common, you get this 4 plus 18 and so on. That is 1974 by 36, 54.83. So what is V of X? Sigma X square minus square of E of X. So it comes out to be 54.83 minus 7 square 49, that is 5.83. So what is standard deviation? Positive square root of variance, root 5.83. See, 2.4 square is 5.76 and this is 5.83. So maybe 2.41, is it? Yes. So somebody has typed 2.41 in chat box. So I'll write that. 2.41 is standard deviation. 15th one, let me explain, but please do write the solution after the lecture. A class has 15 students whose ages are 14, 17, 15, 14, 21, 17, 19, 20, 16, 18, 20, 17, 16, 19 and 20 years. One student is selected in such a manner that each has the same chance being chosen, that is all are equally likely events, and the age X of the student is recorded. What is the probability distribution of the random variable X? Find mean, variance and standard deviation of X. Okay. Solution. Let X denote the age of the chosen student. Then X can take which values? 14, 15, 16, 17, 18, 19, 20 and 21. Okay. So these are the values of X. Tally mark means what? Observation 14 occurs how many times? 2 times. So there are 2 students. In exam, you can avoid this tally mark and you can say that 14 occurs twice. So frequency of this observation is 2 and so on. Okay. Now the chances of any student selected is equally likely. If there are m students with age X, then what is P of X? M upon 15, right? So using this, the following is the probability distribution of X. So value of the random variable is 14. Out of 15, 2 are in favor. So 2 by 15. Then 1 by 15, 2 by 15 and so on. Once you write this, the next part is simple one. So it is mean. Mean is expected value of the random variable, which is sigma xi into pi. So that comes out to be 17.53. What is sigma x square pi or sigma x square into p? Substitute the values, simplify to get 312 upon rather 312.2. Now variance is E of X square minus square of E of X. Substitute the values to get 4.9. What is standard deviation? Positive square root of variance, root 4.9, which is 2. So these are the answers.
Sum 16. In a meeting, 70% of the members favor and 30% oppose a certain proposal. A member is selected at random and we take x equals 0 if he opposed and x equals 1 if he is in favor. Find E of x and variance of x.
Okay, this is simple one. Write down. X takes values 0 and 1. Write the solution. Capital X takes values 0 and 1. We are given what is given? P of x equal to 0. That is P of 0. What do you mean by 30%? 30% means 30 out of 100. Percent means per 100, for every 100. So it is 30 upon 100. That is 0.3. What is P of x equal to 1? That is P of 1. Obviously 70%. That is 70 upon 100, which is nothing but 0.7. Now find out E of x. E of x is nothing but sigma xi pi. So first part equal to 0 plus 1 into 0.7. So what is E of x? 0.7. What is E of x square? Sigma x square into p. So again, first part equal to 0 plus 1 square into 0.7. So it comes out to be 0.7. So what is variance x? Substitute the values. E of x square minus square of E of x. That is 0.7 less 0.7 square. So find out. That is 0.7 less 0.49, which is nothing but 0.21. What is asked? E of x and variance x. So it is better if you write this answer separately. What is expected value? It is 0.7. And what is variance? 0.21. Now we discuss probability distribution of a continuous random variable. Clearly, probability distribution of a continuous random variable differs from that of discrete random variable. Why? Because continuous variate takes all possible values, of course, within certain interval. Now, a real valued function f of x is called a probability density function. Standard short form is PDF. In case of discrete, it was PMF, probability mass function. Here we use the word density. So probability density function of a continuous random variable, say capital X, if it satisfies the following. The first one, that f of x has to be greater than or equal to 0, right? For all small x belonging to capital R. And second, of course, both the criteria are important. Second, integral minus infinity to infinity f of x dx equal to 1. See, this is all about using common sense. In case of discrete, number was limited. So we used to say sigma pi equal to 1. But this is continuous random variable. Of course, over certain interval. But still we say that integral minus infinity to infinity f of x dx has to be 1. And obviously, first condition is f of x should be greater than or equal to 0 for all real values of x. Okay, see, this is not at all difficult. Now, in this case also, we consider cumulative distribution function. So if x is a continuous random variable with probability density function f of x, then the cumulative distribution function of f of x, so it is denoted by capital F of x. In case of discrete also, we denoted it by capital F of x only. Okay, so how capital F of x is defined? It is defined as f of xi equal to p of capital X less than or equal to xi equal to integral minus infinity to xi f of x dx. I'm surprised that in the exercise not a single sum is given on this cumulative distribution. In case of discrete also, maybe it is covered in that miscellaneous exercise, but just remember this definition. Okay, so this is about probability density function. I repeat, in case of discrete random variable, they use PMF, probability mass function, and in case of continuous random variable, they use probability density function. Okay, we'll solve just one sum, so that will give an idea. Exercise 7.2, or before that, just write down this. Exercise 7.2, verify, question 1, verify which of the following is PDF of a random variable x. First one, f of x equal to sin x for 0 less than or equal to x less than or equal to pi by 2. Basically, two criteria should be satisfied. Number one, f of x greater than or equal to 0. Then integral minus infinity to infinity f of x dx should be 1. Now, in this particular interval, is f of x, that is sin x, greater than or equal to 0? Yes, sin 0, 0, sin pi by 2 is 1. Now, let me explain. Minus infinity to infinity, I write this as minus infinity to 0 plus 0 to pi by 2 plus pi by 2 to infinity. But note that for these intervals, minus infinity to 0 and pi by 2 to infinity, f of x equal to 0, because f of x is sin x for this interval. Otherwise, f of x equal to 0. So this part equal to 0 plus integral 0 to pi by 2 sin x dx plus 0. What is integral of sin x? Minus cos x. So minus cos pi by 2 equal to 0, minus minus plus cos 0 is 1. So it comes out to be 1. So we can conclude that f of x is a probability density function. So that's it for today.